So hi everybody, welcome back to in-person session 5 of How to CAD. Today is a very exciting day because I have the honor to for me not to actually begin the lecture, the session, but it's someone else. A good friend of mine, that is Mario. Hopefully he will introduce himself in just a second and you guys will get to learn about his journey. But we both met many years ago, maybe 2019 would have probably been the first time that we met, so that's many moons ago. We were both learning CAD at the same time. We both taught CAD at Penn, our undergrad university. Hello, hello. And I would say, actually, I'm willing to say, even though this will go on YouTube, that Mario is actually way better than me at CAD. So like that's why I would actually take his opinion better than mine on whatever he has to say. Honestly, I remember we would work on projects together on some of the more advanced CAD classes, and some of the stuff that he's done, it's like super impressive. Maybe if you have your portfolio, you can share it like your undergrad one. That being said, Mario, send it off. Like introduce yourself, tell us about your work, your life, anything that you'd like to tell us, and then folks can ask you questions.
Cool, cool. Well, thank you for the introduction. I feel like it was a very kind introduction. Hopefully you can all hear me well. And let me share my screen so I can do the whole introduction thingy. You can see my screen, yeah?
Yes, perfectly.
Cool, cool. Well, thank you for having me. A little bit of an introduction about myself. I think Andy has already said a lot. So I went to UPenn for mechanical engineering. That's when I actually met Andy. So yeah, as he said, we TA'd, a bunch of classes and we actually TA'd the kind of CADing class together. So it's kind of pretty cool to see, what he's now. It's basically the same class you're taking, but at UPenn. It was slightly different. I think he took it to really the next level at MIT. So that's pretty cool. While I was at Penn, I worked at some pretty cool places. You can kind of see some of them here. I spent a summer doing NASCAR, Toyota racing kind of design on next gen stuff. Pretty cool. I almost put a couple pictures, but then, they would have been blurred out and it would have been fun. But pretty cool projects. Michael Jordan was involved. Please ask me about it. But afterwards, I graduated and I actually went to Zoox in San Francisco in the Bay Area. This is the last time Andy actually came to visit. He was very excited about Zoox. No, I think he was just a little bit tired from all the traveling. So Zoox is one of the autonomous vehicle companies in the Bay. And it's pretty exciting for me because compared to other companies like Waymo, they actually build their vehicle from scratch. So what I'm actually doing at Zoox right now is doing underbody structure design. So what I thought I'd do today is kind of give you a little bit of an insight into kind of using the tools that you're learning in actual industry. And if you're excited and interested at the end, I have a little bit of a surprise for you. So what do we mean by underbody? What do we mean by body structures? I swear there's only 2 slides, so don't worry, you're not going to get a lecture on this. But basically, you take the car, even if it's autonomous, and you take, all the seats off, all the, almost the paint, the doors, the steering wheel, all the interiors off, the engine, the suspension, and what you're left with is basically the main kind of big bracket that everything mounts on. So like we call it the body in white because of its color, and it's basically the main structure and safety structure of the vehicle, right? Now this thing, and it's actually made of a lot of sheet metal stampings, which you're also going to see in aerospace. But basically, instead of actually having volumes, we're actually designing sheet metal parts then, and you can see kind of the gift on how they get made. I don't want to turn this into a manufacturing lecture. But basically, this allows us to, keep the stiffness, keep the strength, keep the moment of inertia of the actual components, but have them pretty light because they actually start from sheets and then we actually form them into something. You can see how these parts can get pretty complex, right? And in fact, what I want to show you today is how we would design those parts with tools that you're actually learning, and I'm sure Andy is doing a pretty cool job. So what I wanted to ask you now is, I'm sure you've designed parts before, right? You've had, a little bit of homework assignments on it. This is a part, I can't tell you for what it is used for, but you can, probably imagine a couple of things, but it's used on, automotive/aerospace applications. I want you to take a look at it for like 10 seconds and think, with all the tools you have at your disposal, with Inventor, with everything that Andy taught you, how would you make this part?
I like these challenges. Okay, this is fun. What did
And
I think?
now you could take a look at it and maybe, you might have some ideas on how to, sketch it and extrude it and cut it. But you'll see pretty quickly that this is, as much as it's an easy part, maybe for an automotive body in white, it's actually pretty difficult with all the tools you have at your disposal. So what I wanted to do today, and I'm going to take another 5 minutes of your time before going to questions, is kind of show you how I would design it. And, I design every day these type of parts. I'm going to do it in CATIA, which is a software that we use, but, Inventor has, some of the same capabilities. The only idea that's different is that we're not going to be working with volumes, so with solids, but we're going to be working with surfaces. Um, so I'm
Actually,
actually going to,
before you go, let me
yeah.
let me ask them. Do you guys have any idea of how you would say the stuff that we've learned so far? What could you use? Could you bring yes, like that picture in there, which fortunately it doesn't show any commands yet. So you can look at it. How would you make that part? Could you show us the top view?
Yeah, yeah.
Like so, suppose you're looking at that because this is actually great because we're gonna learn today how to make drawings. So when you make a drawing, like you would see like a view like this one with dimensions. It's difficult, but not impossible. I mean, obviously, what Mario will teach you is like way quicker and more efficient. Any ideas?
It would take a lot of different steps.
Sure, but where would you begin? High level overview.
Probably sketch.
A sketch.
Like the big top. And
Uh huh.
there I would like extrude down into it. And looks like there's like chamfering that was added.
Yes.
And
Yes.
yes, yeah, just like kind of carve it out from the top down.
Mm-hmm.
It would definitely be tricky to make it all like thin all the way around like that, but I think that's the like surfaces.
Like the surface part. Honestly, I think that would be if I didn't do. By the way, I don't. What you're gonna tell us, I've never learned it. So like that's
Yeah, yeah,
it's
that's
cool to have
cool.
it recorded in video. But that's how we do it too. I'll do a big sketch, then start extruding bits. Like do like an extrusion of a slot there in the middle, which is that part, and then maybe like extrude on the side. But obviously that would take a lot of steps. So as a segue, how would
Yes.
you give us
So
the pleasure of illuminating us?
I think you're thinking in the right way. I think the key is, in a lot of, automotive and aerospace applications, we actually don't think about like taking sketches, like 2D sketches and extruding them in volumes, like in 3D volumes. We actually start with 2D profile, like 1D profiles, and then we extrude them into 2D surfaces, which is a little bit of a kind of another way of thinking about it. And I'm actually going to show you because when I look at this part, and I promise I think it's going to take less than like 10 steps. So you could probably think about how many extrudes you'd have to do to get this and how many cuts and whatever pads. We'll do it pretty quickly. And the reason is because when I look at this part, what I see is a collection of like surfaces, right? Now I created the surfaces already, but they could be given to you by other engineering teams. The first thing I look at when I look at this surface is I probably see like a base surface. So imagine kind of the sheet of the gift that I showed you, it's a flat sheet that kind of represents the base of that surface. This flange right here, you see, would also be another surface, maybe something like this. And those are just, 2D sketches that we just extrude, but we're not extruding in closed areas, we're extruding profiles, so they actually show up as surfaces once you extrude them. Something similar with, these bosses, they're just extruded kind of cylinders with, holes. And the holes themselves are actually just extruded, cylinders or slots. The final part would be maybe, the kind of overall shape from the top view. And that also is kind of an extruded edge trim like that. So let's actually do it together. So I'm going to show you a couple of commands that, again, are usual in surfaces. You're going to be like, I've never seen this before. I'm very confused, but that's the point. So just to give you an idea of how different software, different industries kind of use the same tools in different ways. So let's go back to kind of that base surface that we have here, and then we have that flange. In surface modeling, you can actually trim those two surfaces together. And you don't have to learn this, but I can just show you that you can kind of select them together and it's going to kind of knit them and split them together at the seams, just like you were sewing something together. Same thing you can do, with the holes, right? I mean, you have the holes here. You can ask the actual program to say, hey, take this surface and, kind of make sure, that hole kind of pierces through and you actually cut it. Same thing with these holes right here. Again, the commands are not important, but just to give you an idea of how we're actually building this. Something a little bit more difficult is this one. But then again, we can take the space kind of bracket and we can actually trim that shape together. Okay. If you're confused right now, it's probably, normal. You can see here. Of course, you saw there was a comment about some chamfers. We can do that. You usually edge fill it like a volume, but you can actually edge fill it a surface as well. So I can actually select the sharp edge and I can actually fill it that, which is, pretty cool. And I can do the same, with these little edges over here. I'm going to select them pretty quickly and just fill it them. So you can kind of recognize some of the kind of commands that we used in the past, I mean, in your classes, but they are on surfaces. Of course, this doesn't look like, the part that we have because we have to kind of trim the edge. And so that's exactly what we're going to do. We're going to ask the program to kind of take this bracket and trim it based on that boundary and actually trim it based on this boundary right here, which is the X trim. I'm going pretty fast, but just to give you an idea of kind of the flavor of what we do. So that's basically the finished bracket. The only last thing we would do is we would have to actually take this surface and instead of extruding it, we would actually thicken it. So we would actually ask the program to take every single one of these surfaces and kind of make it a little thick. In this case, 0.7 millimeters. And that's how we have the final part. So a completely different way of kind of doing it as you've been doing it. But I think it's pretty cool to see, different ways and different mindset when it comes to kind of designing parts, and in this case for automotive and aerospace applications. And before going to questions, this is the cell. A little bit of the reason why I'm here is, if you kind of are interested in learning more about designing this type of stuff, maybe you're interested in autonomous vehicles, please contact me on LinkedIn. Maybe we have an internship for you. So that's the last thing I'll say before going to questions.
I wish I could be young again and work under you. Just apply. Like, honestly, like, incredible engineer. So I would. No, but this is spectacular. That was so fun. And one little note on that software, which is called CATIA, which you guys asked about. It's generally just like SolidWorks. You need a license to use it, and it's super expensive, which is why we don't teach it here. But at least you get this demo, which shows you like one of the main uses of that software, which is surface modeling. It's a free preview, right? On how this. No, it's like it's the software of like right automotive.
Yeah, you'll see it. Yeah. And you can, this is a very simple part as much as it looks kind of complicated. But if you're designing entire body structures, entire airplanes, right? The parts become very, very difficult and you're basically trimming and splitting surfaces together and you're dreaming about surfaces at night. I mean, it's all the good stuff.
Yeah. Questions for Mario?
I have a question.
Yes.
Yeah.
Do you want to say your name?
Hi, I'm Ruby.
Hiya.
My question is, I mean, maybe this is very basic, but you were using all of those like surfaces and 2D planes. So to make those, did you sketch like the shape in 1D and then extrude it somehow?
Yeah, that's right. So, and I can show you. So, maybe I'll show you one. Let's see if it cooperates with me. So that's one. So and it's not fully constrained. Don't kill me, but just for the purposes of the demo,
You're not fully defining it.
and just because of the demo, and usually, to fully define a surface like that, it would arrive from, there are teams who just do that, as a job. And I knew you would comment on this, but you kind of sketch, yeah, the 2D, like the 1D profile, and then you are actually extruding it. Yeah.
Yeah.
So
Okay.
that's how you create some of them. And then you're doing other things with it. And I simplified, I skipped some steps, right? But the main idea is that one. Yeah.
Okay. Thank you.
Yeah.
Other questions? Don't be shy. Okay.
I could ask.
You can please go ahead before I jump from that.
Okay, I was just gonna ask you about your job at the autonomous vehicles company. What is, I don't know, maybe it's a basic question. What is your favorite part about your job there? Why is it fun to work there?
Great.
Yeah, that's great. I think I'll give you, the main reason, and that is, compared to other companies, or maybe I could have gone into like other automotive, companies. But there is a sense that we're actually, at the frontier of kind of automotive because it's autonomous driving. The car you can see here, or we don't call it a car, just but it doesn't look like a normal vehicle, right? Which means designing parts is very exciting because it's completely different than normal automotive. And then because you're working on structures, which also means you're working on safety, then when you actually ride the vehicle, you kind of know that you designed it, and if something goes bad, you hope you designed it well. Does that make sense?
So are
So you kind of see it directly, yeah.
or is this like a future thing? Like, does it exist yet?
Oh yeah, if you come to San Francisco, you can ride it.
Wait, no way, really?
Yeah,
Oh.
You have
and
to
you
stop
should.
yeah, it's under debate. What advice do you have for, say, young students? Say you could go back to when you were a freshman, right? Now you know all of this stuff, and suppose you didn't know it. What would you tell them to explore? Or what
I
are
think you
some
just, so in terms of like work opportunities and kind of gathering skills, just try to work at the most random, exciting places you can find. So I'm from Italy originally, international student, and here I am, interning for a Toyota racing team at NASCAR, right? And I only said yes because it looked kind of cool, and in fact, I learned a lot. I think I was maybe their first international intern. I remember as a thank you, I think we were at the racetrack one day and they got Olive Garden for me as a thank you. I don't think they understood
the
what.
finest Italian cuisine?
Yeah. But I think that the main piece of advice is try to work as, the more exciting, more even random places possible because you're going to remember those days, fondly, and you're actually going to learn skills that you're going to use, somewhere else. So in the same way, I could have gone at a normal automotive company, but Zoox was, cooler, and I do not regret, my choice.
Thank you. And then one question just for like personal curiosity.
Yeah.
There's so many CAD softwares out there.
Yeah.
Like how difficult was it for you to learn CATIA? And do you think there's like any, say you learn Inventor as an example in this case, or Onshape, SolidWorks, like how big would you say are the differences among them?
So I think once you learn, you can learn where all the buttons are, and they may have different names, but the ideas are the same. I think the main kind of the thing that took the longest was the mindset shift between working with surfaces, right? So having 1,500 extrudes and cuts and pockets and whatever, to working with surfaces,
Well,
right? And kind of visualize. So right now, you might have a drawing that Andy gives you, and you might visualize, okay, I need this extrude. I need this sketch, I need this cut. Going from that to surfaces where you're actually thinking in terms of surfaces, right? And offsets and trims. I think that's what takes, kind of the longest time to learn. The best thing you can do is when you go to these companies that use these software, please ask them to send you over like a CAD part, that's great and very well constructed, and just study it, right? Because some of the more complex ones have, project trees, that have thousands of, different operations. So it's pretty cool to see, as the design progresses, what the designers were thinking.
this is going to be the first time and only time that we will design something using a drawing. A drawing, and you guys know what a drawing is? You just specify all of the dimensions. And I think the canonical example is a Lego brick. This is right. This is the brick, and these are the different dimensions. I'll show you how to read it in just a second, a simplified version of this. And we'll make, say, a 2x4. And very easily, if you save as the part, you can make a 2x2, you can make a 2x3, you can make all sorts of bricks from that one. Once we've all done that, then we'll use this to make an assembly. The activity would be to make the tower bridge, but it turns out making the tower bridge is a 2-hour long activity. So we can just build any assembly that you want. And once we're done with that, we will use all of that stuff to make one of these, a drawing. So we'll make a brick, we'll make an assembly, we'll make a drawing. Relatively simple, but at least once you master these skills, everything, like you'll be able to do a lot of things. Okay. So let's go here to Inventor. And this one is, for me, it's so standardized because I've had so many bricks in my life. And I was thinking today doing a Duplo brick. Duplo, like the kids bricks, but the problem is I couldn't find the dimensions for that. Meanwhile, for Lego, like these are, I'm not sure how I found them in the first place, whether I came with a caliper and I measured it myself or whether I found them online, but these I know are mostly true. So what I do encourage you is when you do design your bricks to make them, add some qualities that make them your own. Make them your own branded Legos. Anyways, so we'll go here to the sketch. We'll go here to XY plane, and we'll start reading this thing. And the first thing that you can see is that, well, first, there's a note that says the units are millimeters. So what do we do? Just as a little reminder, actually. Tools, application option. Actually, I think it's here in settings. Units, millimeters, and grams. Okay. Just as a little. Anyways, back to edit sketch. And we go to the drawing. So it says it's 32 by 16. And then this is extruded by 9.6. So let's do that. So I'm going to go here to sketch. No, actually, I was already in sketch. Sorry. Let's go here to make a rectangle. Put it in here. Let's make that 32. Let's make that 16. And we're going to extrude that by 9.6. Okay. And then the command that we can use if you look at the drawing is that, you see how it's like hollow in the inside? That command is called shell. Which is, and maybe some of the stuff that Mario was showing us, you could have modeled it using stuff like that. But you click here in shell, and it's going to ask us like, how thick do you want the walls to be? And in the drawing, you can see that it says 1.2 uniform wall thickness. How you can see that? You can see it either from here or from the fact that that's 9.6 and that's 8.4. So that's 1.2. So we'll write that in there. We'll go to OK. And then we'll go here to sketch, and we'll do a sketch on that face. And now we need to start adding the characteristic stats. And we are told that the stats are diameter. Please don't tell me that I forgot to specify the diameter. Oh, I keep on finding, I keep on finding flaws in my drawings. There's always one dimension missing. And I think the one that is missing right now is the diameter of my circle.
You can calculate it, I think.
No, well, I know that one is 2.4. No, it's not. I think it's 4.8, if I'm not mistaken, the diameter. I just remember the dimensions. But you see, it's always good to check these things, but this is missing that part. So in fact, I might edit it later. But we go here to Inventor, so we'll do a circle. And at least the part that we know is that it's 4 and 4 from the edge. So we go here to D. I click on that point and that line will make that 4. By the way, did you guys ever play with Legos growing up?
Yes.
Yes. Legos are expensive. Very expensive. I'm not sure whether you've been following the trends in the market these days, but it's easier to play with a free Inventor license and make your own bricks than actually to buy them. And I believe the height should be 1.2. Okay.
Get a 3D printer.
And just print your own bricks. In fact, you can make them better. Yeah, it is sad. Anyways, and then another thing that we're told is at least the Lego extrusion, like There's even dimensions for that stuff, but not for that circle. That is outrageous. I'll have to modify this. But then it's telling us that it's a 0.1 up there. But instead of calling it Lego, what I'm gonna do is I'll call it CAD. So what we can do is go here to text. Actually, let me first draw a line that goes like that. And I can say, all right, I want the distance between here and here to be 0.65. I think that's what the drawing said. Then we can make that a construction. And then if we go to text, there's this one that's called geometry text. And we click on that line and we can call this one CAD. And we can say, I think the font type is Calibri. Even the font type is specified, but not that diameter. I'm ashamed with myself. Calibri, there we go. And let's see. All right, so that's too big. So we can double click, center that, and make that 0.02. Free. Okay, let's see. Well, that's too small now. So let's make that 0.08. Oh, it's always a little bit of trial and error, as you can see. 0.06. Okay. Decent. Maybe I might modify that to be 0.8, just slightly down. We'll go here to extrude. And we'll select, wait. 1 second. Actually, maybe I need to.
Oh, wait, you selected it for a second.
No, I know. It's just sometimes it's easier if I just exit. The first. It's a little bit annoying. I know. And then 0.1. So now we got the word CAD written in there. And then one last thing that we'll do before I let you guys go is that I'm gonna go here to sketch, click this bottom face in here, and I'm gonna do a project geometry of that little circle. Why am I doing that? Because what we're also told in the drawing is that you have these bottom studs down there. So these are 2.4 and it's a 1.2 pocket. That makes sense because it's uniform thickness. So I'm gonna draw a circle. We'll go letter D, and that's 2.4. Oh, sorry. 2.4. We are gonna extrude downwards by 1.2. Good. Okay. So last step, but penultimate step is that we go here to rectangular pattern. So select features, we'll do that extrusion, the word CAD, and that one down there. And then for this direction, let me just invert it for a second. Let's make that 8, and let's make that 4. And then we'll select another direction. By the way, this technique of doing it, I'm not sure whether you guys have seen the next video, how to make configurations. This will make it super easy to then modify parameters. Say you give me equations, I'm making any brick that you could imagine. Now for now, we'll leave it like this. I'll say, okay, where did I take this? Because I know from the drawing that that's 8 and that's 8 and it's a linear pattern. And what are we stuck with? This. That's a 6.4 circle with a uniform thickness of 0.6, and it's also 8 and 8. So let's do that last detail in there. So I'll go here to sketch. And I think the first one that we drew, we're gonna draw it from this side. So let's draw a circle, letter D. Let's make that 8. Let's make this 8. This is 6.4. Now offset. Let's make that 0.6. And let's bring it all the way up to, there we go. There's this one that you can say, I want to go up to this face. So now you got that. And then lastly, rectangular pattern, select feature that, direction is gonna be that, the opposite direction, we're gonna make 3 and 8. Ta-da! You got your brick? And now because I'm a little bit quirky, I don't want those edges to be flat. So our version of the Lego brick will have chamfers in there. That way it looks like a real Lego brick. I say, okay. And then what we can do is select all of these guys in here, go to properties, and Let's make it. Actually, you know what we could do? We can make it gold. There's literally Lego bricks that are made out of precious metal. These are very rare. I mean, they're given to the employees after working like many years in the factory. No, I'm not kidding. This is like the lore that I've read online. And then you can obviously make it a lot nicer by adding fillets and whatnot. The problem is that when we add this into the assembly, what's going to happen is that there's going to be a lot of detail. So you have to like balance how much detail you want to put into your piece. For instance, when I made the plate, like the bottom plate, it was like a lot of, it was lagging a lot, the software. So this is it for the brick. Any questions? Okay, if not, what you can do is go online to our website. Then, so suppose you make it all the way here, click on session files, then go to session 4, session 5, sorry, and go to 2x4 brick drawing. And that's where you can find this. So try to make it. This circle, I apologize again, 4.8.
What's the website?
Oh, you can look in the email.
Oh, okay.
Or like the just type how to CAD, it might be.
Oh, okay.
It will appear.
Are you going to use it?
No, but I don't think Inventor is working.
Okay. So that one then.
Yeah. So let's take maybe like 15 minutes, 20 minutes doing this. Here, just come over, and then I'll let you guys continue. But I mean, the part that comes next is the fun part, honestly. This is the part where you've done the labor to create the brick, so now you can use it to play. So what do we do? Well, now we go here to File. Actually, first save it. There we go. Now we go here to File. We go here to New, and now we'll choose Assembly. So now, here, do you wanna let me show you? So why do we care about assemblies? Because I was just bringing this one from before.
Wow.
You can try to make this if you have a lot of patience. At one point, it's no longer fun and it's pain that I click so many times. But yes, this is the whole point, is to use Lego bricks to learn how to make assembly. So now, what is the gist of this? So we start here with this command that's called place. And we'll go there to place. And I'm gonna bring this brick right there. Boom, and I click on escape. And then I go here to view. I'll change it to shape with edges. I do not know why it changes. I can leave it like the visibility, but I leave it like that. So this is our first brick, and we can move it around. Generally, the first thing that you bring in space, you want to fix it. That way, everything else that you do, which will probably build with respect to that one, will be referenced to that one. So that this brick will act as your origin. So how do you do that? You go to your brick and you go to where it says, let me see if I find the grounded. It's that button right there. So you see how it says O in that little icon? If I change it to grounded, now that icon is fully colored. It's very subtle, different. Then there's like a pin. In other words, if I click on this, I can no longer move the brick. And why do we want that? Because now we'll go to assemble and let's bring more bricks. I mean, we could actually bring anything that we've done. I could bring like the Playmobil, the trumpet.
Bring a banana.
We could bring the banana. Well, the banana. Actually, we could bring the banana. And then, even though I'll stick to bricks in a second, but this is an example of an object that is much bigger than the other one, right? Like the banana. But what can we do? This side of the banana, yes, it's gold banana. It's an expensive banana. This side of the banana is flat, and this side is flat too. So we can start to constrain things in space using these things that are called constraints, literally. But they are, if you use other CAD software, these are mates. How you stick things together. So you go there to constrain, And the classic one is this one, which is called mate. So I can select face, for instance, that face and that face, and now they're touching. That's one option. It's that one right there where they touch. Another option is the other one, which is they would be flush on one direction. So they can be touching face to face from one side or the other one. I can say, okay. So what does this do? And now this can only be moved. So it's constrained to that surface, this side of the brick. But now I can move the banana only up and down or sideways. Believe me, it is stuck to the brick. Now, I don't have any other flat surfaces on this stuff to constrain with this. So maybe I'm gonna delete the banana. But let me bring some more bricks in here. Actually, I could bring the Diet Coke, but it's okay. When I bring this another brick in here. So say I wanted to build a row of bricks, right? As an example. So let's start with this one right here. So we go here to constrain, and you have that one right there. There's multiple ones. You could also define it as an angle, define it also just to be tangent, which would be that particular case. But this one is pretty much universal. You can use it for anything. So I'll click in here on that face, and I click on that face, and you go there, and you say apply if you don't want to finish. So actually, I'll click on escape, but you can again move it on this side. Now we go back to constraint. I can click on that face and that face, and now let me just make it flash like that. So I just change that button. I click on apply, and then this face and that face, and I click on OK. So now that brick is also fully defined, and you can see how there's a like that dot in there is fully colored. It's very easy. So like now, this is how you build with bricks. Now, Legos are interesting because also you have the stats. So I could also bring another brick. Let me place this one right here. And instead of using this constraint, I could do joints. Joints is where you start to get a little more creative with the angles and rotations. So I can choose, for instance, this one that's called cylindrical as an example. So I can click on that face and that face. And see how it's let me just click on. Yes, it's rotating all around. Let me just escape for a second because I have to be strategic about when I click OK. Let me do OK there, right? Oh, where did it? Oh, there we go. Excellent. So now this thing is constrained that the axis in here and the axis in there are always in there.
Does it have to be the same diameter or?
No, it could be any diameter.
So.
For instance, a great question. I can bring the Coke. Which is right here. Oof, big boy in here. By the way, when you have a situation like this one, I could select this object, there, the Diet Coke, and I could free rotate. So I can just rotate it around.
Can you make it smaller here?
I could do, actually, great question. This is as an aside, right? But let me open the Coke. And let me file save as Diet Coke. This is actually what we're gonna do now. Great question for asking. It's the reason why we don't normally care about your dimensions, right? And then you direct, all right, scale 0.1. Oh, sorry. It's just. Oh, finally. And then I could go. There we go. So now you have it in there. And it looks identical, just like that. Which is difficult to find it. Just as a reminder, go here to direct edit. It's that one there, which otherwise is this one in here. Okay, their terminologies. But now we go to our assembly in here. Let me delete that Coke and let me bring this other one in here. Okay, so now yes, it's significantly tiny. And then we're gonna move. No, there we go. So then you have this stuff, but then you can get you can simplify your life a little bit. For instance, by making patterns. you can select on, say, feature could be that, and then you can go there and say, all right, I want to go in that direction, and I would like to have, oh, that's in inches, so maybe I'll say, let's do 16 millimeters. Let me click and then row maybe that. Let's see what happens if I, sorry, I don't think I'm doing this correctly. Component, there we go, okay. But this one, I only want 1 unit of this thing, and I click on okay. So that's like how I was, when I was doing the tower bridge, like say for some of these roads, it was easier to just make it like a nice linear pattern in there. Yeah, so that's like essentially it in terms of like constraints. The one to use the most is that one that's called MAPE, or this one that's called cylindrical. But there's these ones are perhaps a little more complex. Like this one is like a ball joint as an example. So you have like a curved surface and another curved surface, like two spheres, and you could have them like both around each other. But not today. Not that one in there. Questions about this? The what?
Yeah,
Oh, those ones. Let me. I think they may have appeared from before. Let me. Oh, because I think I know why. I also selected that one. If we go here and I edit this thing, I also selected that brick. So now I would have to unselect it. That's fine. Maybe one last thing is, let's figure out that one. Like why you can always edit your constraint in here, but let's say I delete that one in there. Let me do this one more time. So go here to joint, cylindrical. So I'll start with this one. We are sure that that's the middle. Around the constraint. Oh no. Let me select maybe that one right there, and then that one. Okay, now it's correct. Okay, just make sure that it's properly done. Now play. Let's take 30 minutes until, actually 20 minutes until 4:30 to make an assembly of your choice. Just have fun. So you start here from place and you choose the object that you want, for instance, this one, and I bring it in space. And then what you do is go here to this button, right click, and you click on grounded. So you see how it creates a pin. And also, every time you fully define something, so you have freedom X, Y, and Z, and you always have to fully define, that dot becomes fully covered. Good? Pleasure. And then I can give you like a quick demo. Yeah, like, so let me, fortunately, it's just Lego bricks, so it's relatively easy. But I can go here to place, and I'll bring like another brick. You can download the bricks from the website if you want, to keep it simple. And then you go here to constraint, and the easiest one is this one that's called mate. So you select that face, you select that face, and now they're touching each other. You click on apply, I select that face and select that face. And I just have to make sure that it's the appropriate one is selected. So I go for that one and I click on apply, and then that face and that face. I click on OK. Now I can bring another brick, for instance, that one. And I can say, well, I want to constrain that face and that face. So they're now touching each other. Then this face and this face. Just like that, I'll go for that command. I click on apply. And now I can say this face and that face. However, I can offset it by, let's do 16 millimeters. Because that's like the size of the brick.
Yes.
So now you have something like that. And then suppose I wanted to put a brick in there. So you go here to place. So I go here to brick. And now I could select that one. And where is it? Rotate. I can rotate it like that. And then constraint, face, there we go, apply, then that face and that face. And then we can say that I want that distance to be 8 millimeters. Oh, Oh, I think I had to change the mate type. Do that one. There we go. 8 millimeters. Ta-da.
Okay. Yeah.
And then if you wanted to change their colors, by the way, you select your brick of choice. You go here to finish, and you can say like properties, like aluminum, actually. Or you could like color them like that.
Okay.
Okay.
Yeah, yeah.
Again, for you guys that are here, if you wanted to change the colors of your part, it doesn't matter which colors you used on your original part. You can go here to finish and then click on this one that's called whole body. And I can say, right, I want that. So that one has to be platinum and that one has to be like that. So I'm gonna change this to aluminum polished. And then I can go, then I get to finish to that box and say, right, I want these two to be gold. So something nice, that way you can, the fact that it allows you to change the colors in the assembly, it's way better than having to like to do it after, like in individual parts. So yeah, so this is like super easy to do, like something that looks complex like that, right? Just a pattern and then just defining 60 degrees with all of them and you get this nice DNA structure. Anyway, now we'll go here to file, new drawing. So this is what appears. So this might actually be the most important thing that you learn throughout all of the sessions, because you might make a CAD part. Let's say you work in a research lab, well, why not? They will ask you, how do you machine this? How do you manufacture it? So you need to provide at least some key dimensions. So the drawing that I'll show you now is, I would call it a low fidelity one, which is, suppose someone needs a block of metal to make this thing. Well, how big should that block be? So, well, it has to be at least as big as the part itself, right? So we can provide some general dimensions, or you can go like full on. So what I'm gonna go here is I go here to sheet, and I'm gonna go here to where it says edit sheet in there. And there's multiple things that you can change. For instance, whether you want this to be a portrait versus a landscape, which is the current setup, whether you want that box to be here, here, or here, you can change the orientation like that. Or for me, the most important one is this is a drawing that it's letter D. Like, I think it's like a massive drawing. I generally go for A4, which is the size of pages back home. I think here it's, what is it, 8.5 by 11.5 inches, something like that. So roughly like an A4 piece of paper in Argentina. And then if you go here to drawing resources, you see a bunch of things such as like title blocks and also like this one right there. So this one is called ANSI large, but you could also, if I double clicked in there and I click on yes, it changed the size of the block to this one that is also available, which is ANSI A. Now, what we can start to do is right click in here and go to edit definition. And we go here. This is literally, you see how we are in Sketch? That's a sketch. A drawing, like especially if you've used other Inventor softwares more well known like AutoCAD, they're just sketches, just 2D stuff. So it doesn't surprise me, right? That when you're here in the drawing interface, you're literally drawing lines. And most of this stuff, I actually don't need. So I'm gonna actually go ahead and delete a lot of those things. These are like, if you want to make a super extensive drawing, I'll make that one 0 as an example, and I can make that be 5. So for company, we can say, I'm gonna delete that and say how to CAD. And then title can be Legos. I mean, it could be, all right, this is the Lego Rig 2x4. And then like drawn by, By the way, the reason why it's in parentheses like this is because there's a way where you can input all of this information in a nice, like programmatic way. It's just that this gives you more control to edit all of those stuff. I'd rather do it manually. So you can call it Andy, and then just for simplicity, I will delete all of those. Delete, and I can get rid of all of these lines as well, because I don't need them. Delete them. I don't think we need that one either. Delete. And delete. We can delete. There we go. And then once you're done, yes, I think drawing number, we can call it drawing number 1. Revision number, we can call it 1. Yes, that's fine. I will go to finish. Save, yes. Ta-da! So you have like the most important part, which is an identifier to your drawing. And this is probably where you would add, oh, all dimensions are in millimeters and stuff like that, like especially certain things that you'd like whomever reads this thing to be aware of. You want to edit it again, go back here to ANSI A, edit definition, and you can go back there. Okay, we haven't done anything yet. This is blank. Let's start doing some fun stuff. So we go here to base. And well, right now it's selecting the assembly, right? Because it allows you to make a drawing of the assembly. We're not going to do that yet. We're going to do one of the brick in here. And I can go to OK. And I click OK. So a bunch of things is that if you double click in there, you can again see all of that view. Let's make that bigger. Let's make it 4 as an example. And now you see how it's weird. It like shows you some of the hidden edges. I don't want that to be the case. So I can double click again on that and modify the parameters in there. For instance, I can make it fully shaded and click on OK. Actually, I believe, there we go. I have to check on that one. So that's fully shaded and without that stuff. Or normally the one I like doing is without just the regular line. The one that is normally fully shaded is the one that goes in the diagonal in there. So drawings normally have, if we go back to how to CAD, have a bunch of views, top, side, bottom, another one of those side views, and that one that's called isometric. That's like more like the standard way of building them. So we can add exactly those. However, you see how this drawing has this thing that's called a section view. That's if I grab the piece and I chopped it in half, and that's what you would see. So how do you do that one, which is probably the most important view that you could add? Well, I'm gonna drop this guy here. Actually, I think I'll need to make it smaller, but I'll go here to free. I'll leave it here, right? What you can do from like this view right there, you can go to place views and add, well, let me just projected views out of this. So you can click in there and add a side view. You can, oh, sorry. And then click again, and then click is, oh my goodness. Where is it? Create, there we go. Now I'm gonna click in here, I'm gonna go down, and I'm gonna right click and go to create. There we go. And then if you move like the main one out of which all of these are referenced from, all of these will be moved as well. So I'm just gonna move it like that. You can place them wherever you want. And then to add the one that is the isometric view, you go again to projected view, you click off from that one, and I'm just bringing it like that. And right click, create. And that one I can place it, for instance, there. And since it's like the view that shows you more or less how this thing looks like, I can right click, I can double click in there, and we'll give it color. There we go. So I'm gonna leave that in here. You can add as many dimensions as you would want to add in here. We can keep it simple and say, go here to annotate annotate here to dimension, and then click on these 2 lines and say, all right, I want, but you would add dimensions like that. So an annotate dimension, I'm gonna add these 2 in there like that. And then you would say, right, let me add one more, maybe from here, from that face all the way there. That's 0.43. And then you can go here to text and say that is top view. Again, leave it right there. And go here to text. I call that one side view. So on and so forth, right? Like you can be as detailed as you want. But this would be a drawing that from these dimensions, all that you can see is that this thing is 63 in this direction, 1.26 on the other one, 43 like that. So you need a rectangular cube that is that big if you wanted to machine. There's like nothing too fancy from there. But this is like pretty much it in terms of drawings. You can also like add comments. You can say something like continue, and you click like 8x linear pattern. I click on OK. Just like that. And you can like, oh. It's funny how you have to like move it through all of those little green dots in there. So you can be as detailed as you want. Maybe if you're gonna try to replicate all of these dimensions, don't forget that 4.8. But now it's there. Yes, I'll go ahead and try it. I walk around and I'm gonna figure out in the meantime two things, which is the section view part and also how to change the units to millimeters. If you guys go to tools, then document settings, literally instead of using default standard ANSI, you go to default standard ANSI millimeters. That's it. So then you click in there, and then obviously if you've already drawn dimensions, they will still remain in inches, but all new dimensions that you draw will be in millimeters. That's good. So we figured out that part. Oh, there we go. That's how we can make the section view. So I'm gonna get rid of that one. Delete. Click. Well, I'm gonna stop the video here.